Morning, everybody.
I like the eeriness of the fog outside, pretty good. It'd be better for Halloween for our exam day, wouldn't it?
A couple things I want to kind of set the calendar. So today we're going to finish up chapter 6. I only have one little area I'd like to cover. We're not going to have a chapter 6 quiz. The only reason for that is I don't like to give you a quiz and an exam at the same time. So I can if you want. I can have that ready. If you like that, does the quiz help? Quiz helps?
Yeah, I think so.
All right, so I can set a quiz up. What do you want to do? Well, I think you guys, yeah, but people do pretty well on the quizzes.
Friday night, yeah.
Right.
Friday night.
Friday night? You really think so?
Sunday night.
Sunday night, I think. All right.
Well, I
Sunday
just
night.
remember it's a test Monday.
Yeah, but people like Friday nights. Not ever. I don't know if I've ever made anything do Friday night. That's not good. So Sunday night, I'll have chapter 6 quiz prepared. I'll do that after class. That'll be due Sunday night. We're going to review for the exam, which is Monday, and also have a little video I want to start to show you guys. So we're in chapter 6, and we're talking about networking and the cloud. And we talked a lot about how the internet works, how a network works, all the hardware involved there. There's a lot of things going on, how the domain name system works, the miracle of the internet. We also talked about the 3-tier architecture, that there's a user tier like the device you bring. We also talked about the server tier, so you're going through the internet hitting a server. And then somehow, if it's going to be dynamic, meaning changing, there's a database involved. And we use Amazon as an example. Different products load different content in the pages returned to you. And what we kind of left off on is, we've been talking about this thing as a cloud. And there's some good business terms, some IT terms that you should know. And the first one is software as a service. And it's always written this way. So big S, uppercase S, two lowercase a's, and an uppercase S. Software as a service means software in the cloud, like everything is in the cloud. For example, when we use Brightspace in this class, that was in the first course management system, that was a good example of software as a service. St. Francis did not install it on a server here, okay? It wasn't installed on your computer. Brightspace, which is Desire to Learn as the company, has a server somewhere in the cloud. We don't know where it is. We don't care where it is, where they had an instance of that running for us, right? You just cooked it in the internet. So software as a service is, iCloud is software as a service. There's no server installed in your home. You use iCloud on the internet. Office 365. You guys know what Office 365 is? That's like the online version of Microsoft Office. Salesforce.com, which is a kind of a customer relationship management package. These are all examples of software as a service. So that is the highest level. Like the highest level meaning everything is taken care of for me. All I do is go out and use the software. I get a sign on. I go out and use the software. It's somewhere. I don't care where. I don't know what's going on. It's somewhere. It's like my last 2 days, my voice is like changed. Has my voice changed? I'm going through puberty again up here. I don't know. Reverse puberty. I've been struggling with it. I don't know what's going on. So software as a service is like the most turnkey, if you would. And that's where a lot of companies are going, right? Gmail is software as a service. You don't care where those servers are. You just use it, right? That's software as a service. The next level down is platform as a service. Okay? Platform as a service, meaning you still run your own software. It's software that you're installing, but you're installing it on a platform somewhere in the cloud. Microsoft Azure, Oracle On Demand are examples of this. Like I want to install my own software, but I don't want to maintain my own servers. Okay, I don't want to maintain my own servers. I'll install it in somewhere. I'll contract with Microsoft or Oracle and install it somewhere in the cloud. So it's my software, right? It's something maybe I've developed or maybe something I've purchased, but I'm installing it on the cloud. I'm not maintaining the servers. Does that make sense? Yes. So that's like another level. And the third level is infrastructure as a service. Infrastructure as a service is kind of like the base level. You say, I want to contract with Amazon in the cloud to own maybe a few terabytes of storage, and that's called EC2, Elastic Cloud Storage. Or I want a few servers that I can spin up. So infrastructure as a service is the base level. That is, you're actually acquiring like the hardware resources in the cloud. So this is the most turnkey, this is the least turnkey, but these are all examples of using the cloud, okay? Software as a service is, as a business professional, that's the one you're gonna see, right? When we talk about running things in the cloud, software as a service is what we're doing, software as a service. We're contracting and using that service, okay? That's all I really want to talk about with those. The last thing, though, that I think is worth defining is the term VPN. What's VPN? What's VPN? Anyone hear of VPN? Maybe it says it up there. No, there it goes. What's VPN? Maybe your parents use VPN, I don't know. VPN stands for virtual. Anytime you hear the word virtual in IT world, it means something that appears to be different than it is, right? So virtual stands for virtual private network. So I may be at somewhere in the world, and I want to look like I'm at my workplace where I have access to everything on the network, like printers and maybe scanners and maybe the shared network drives. Well, I can go through the internet, okay, through the cloud basically, and it creates what's called a secure tunnel, and we connect to a VPN server, and it looks like we are at our workplace. So when I log in from my, maybe my Malaysian hotel, it looks like the same as my desktop here in Loretto, and I have the same access. I'm logged into Novell. That's called a VPN, or virtual private network. And a lot of people, because telecommuting is so prevalent, because business travel is so prevalent, they use VPNs to connect to their workspace, right? Because it looks like, just like it looks like when you are in your own network, okay? VPN, so virtual private network. There's some other things in this chapter, but I think that's all I'm going to cover, okay? That's all I'm going to cover, and that's all you'll be responsible for the exam, okay? All right, any questions on chapter 6? All right, then let's go out to Blackboard, and under exam review documents, I'm not sure if you noticed this, but I think I put it out Monday. I have out here exam to review, okay? And this, our next exam will be Monday, October 31st. 50-minute exam, 100 multiple choice, 100 points, 35 multiple choice, 4 short answers, 1 potential bonus point, and it's closed book, closed notes, okay? So the material for this chapter, for this exam, 3 chapters. Chapter 4 was hardware and software. So the material for that is chapter 4 of your text, chapter 4 PowerPoint slides, classroom lecture via YouTube, and the topics that we've covered. Okay, so basic hardware components. It seems like a while ago. I think it was, obviously before break. But we talked about input, process, storage. We talked about central processing unit and RAM. We talked about volatile versus non-volatile memory. What's the difference there? I think I told you the corny Bill Gates joke. What's the difference between volatile and non-volatile memory? Volatile memory goes away when you lose power. Non-volatile memory is something like stored, like on your hard drive, like it's saved. RAM, random access memory, is volatile memory, right? Whatever you're working on, a lot of times goes away when you lose power or turn things off. We had a basic understanding of binary, right? What ones and zeros and how that translated to numbers. Remember I said everything comes down to ones and zeros, bits. And one thing I do want you to understand is the prefixes that are used for sizing things. So, kilo basically means 1,000. Mega basically means 1,000,000. Giga means definitely 1,000,000,000. And you probably don't need to know peta or exa. You don't. I mean, it's good to know, but you won't have to know for the exam. But I would take you up to tera, understanding it. So every level we go up is going up a factor of what? 1,000, right? So if you know the order, this is 1,000, this is 1,000,000, this is 1,000 megas, you know what I mean? So it's 1,000 level up. Every prefix is 1,000 level up. So there'll be a couple multiple choice related to that. We talked about magnetic disk and optical disk. We talked about client server applications. We talked about the difference between operating software and application software, like operating software that drives your system. We talked about different examples of that: Windows, Linux, iOS, Android. That's for your, those are all examples of operating system. Application software does something. Okay, application software does something. We spent some time talking about open source software, where the source is open, it's free, advantages and disadvantages of that. We talked about licensing. Software is copyrighted. So when you buy software, you don't buy the software. If you bought Microsoft Office, you'd be very rich. You buy a license to use it. And there's different types of licensing: seat licensing, enterprise licensing. We talked a little bit about upgrades and maintenance fees. We talked about types of software applications, and we used the terms horizontal, vertical, and one of a kind. Someone tell me the example between horizontal applications and vertical applications, or give me an example. Horizontal versus vertical. Go ahead.
Vertical applications are kind of like used in the industry.
Sure.
Company, and then horizontal are other like applications that are used across multiple.
Very good. So Blackboard would be an example of vertical software because it's used in higher education industry, right? Email is a, did I say horizontal? Go like this. It's vertical. Blackboard is vertical, right? Email would be horizontal because you use it, Microsoft Office would be horizontal because you use it across many industries. One of a kind means it's something we do so unique that only we need that software. And that lends itself to kind of the next chart, is how we acquire software. Typically, if it's horizontal or vertical, we buy it off the shelf, right? If it's something everyone needs, well, someone has spent a lot of time developing payroll software. So why would we develop our own payroll software? Let's buy it because they've spent a lot of time and money doing that. We'll buy it for a lot cheaper than we could develop it ourselves. So that's off the shelf. We can also do off the shelf with little small customizations. If it's something so unique to us, a one-of-a-kind application, we have to custom develop it. And I think the example I used was like buying a suit, right? If you buy a suit off the rack, that's like off the shelf. If you buy it off the rack and have it tailored for yourself, that's off the shelf with customizations. Custom developed is a tailor-made suit, right? Someone measures every nook and cranny of your body, makes a suit just for you, very specialized. And the price is the same, right? All those things cost more and more money. In fact, custom developed is a factor of a lot more money. So what acquiring method, and these kind of things, that's what I just talked about, they're kind of related. And we talked about thick client versus thin client. What's the difference between thick and thin client? What do we mean by thick client and thin client? It kind of relates to what we just talked about. Thick versus thin client. So cloud-based solutions require what kind of client? Thin, right? Because a lot of the processing software as a service happens in the cloud. I don't need a lot of storage space on my computer. I don't need a lot of processing power. Thick client means, I need that stuff because I'm installing things right on my computer, right? So thin versus thick. And we've talked that, industry is moving more toward cloud-based and thin client kind of computing. So that was hardware and software. I don't think anything, earth-shattering in there. Any questions on chapter 4? Chapter 5, we spent a lot of time in Chapter 5. It's an important thing, understanding databases and database processing. Why do we need a database as opposed to a list? Why do we need a database as opposed to a list?
The database shows the relationships between them.
Okay, so if we're storing information about one theme, a list works. We can put it in a spreadsheet, it works. But if we need to relate things, if we're storing information about multiple things, like students, student appointments, student grades, student housing, then we need a database. And you're right, a database is tables plus relationships plus metadata. You guys remember that? Tables plus relationships plus metadata, which is data about data. So we talked about a definition of database, and I really want you to understand the hierarchy of data, how it all comes together. If you think about it, at the very level, everything in computers comes down to bits, zeros and ones. Those bits come together to form bytes. Those bytes come together to form characters. Characters go in columns, fields, or attributes. Like if we're talking about like last name, like Miko is 4 characters, and that's a last name column. In the row for like faculty member, right? There's a row of information about John Miko, which is in a table called faculty, which is in a database called, St. Francis University, right? We built those tables, right? We brought those tables together. We talked about, faculty teaching courses, students enrolling in those offerings. Remember, all those tables came together. And when we talked about that, data types are things like, what were data types that we used? So when we built income, what data type was income? Remember when we used Microsoft Access? The drop down, what data type was income? Currency, right? Name was text, yes? Those are data types. Metadata is data about data. Relational database, we talked about that. And what's the difference between a primary key and a foreign key? Primary key versus a foreign key.
Doesn't a foreign key take it to a primary key?
Very good. A primary key is a field or combination of fields that uniquely identifies every row in a table. Typically your user ID, your account number, your social security number. Something that makes you unique. Name doesn't work, right? Because there's a lot of Bob Smiths in the world, yes? So it has to be something uniquely identifies you. Your account number, your driver's license number, whatever it might be. That is the primary key. A foreign key is a key in a table that then points to that primary key. It says, this is you live in Lewis Hall, and so in that student table, it points to Lewis as the primary key in the dormitory table. So primary keys and foreign keys build those relationships. We also talked about in database management systems, some of the things we can use. Forms, kind of a structured way to input or see data. Talked about reports, instead of looking at the tables, we built reports that came back and had things structured nicely. The last two are kind of related, queries and structured query language. What is a query? Query is it's a question, right? It's a question. So a query of a database is, I'm going to question this database. I want you to return all the students that are juniors that live in New Jersey that have a GPA higher than 3.0. That's a query, right? And I want you to pull all those students and maybe where they live and what their phone number is. That's a query. The language we use to communicate with relational databases is SQL. Language I'm using to communicate to you right now is English, right? SQL, structured query language, is how we question databases. That's the programming language we use to question databases. So, that was kind of chapter 5. Chapter 6, the clouds and the networks. A lot of terms in this chapter. I think a lot of important terms. We talked about PAN, LAN, WAN. What's a PAN? Not the frying type, but what's a PAN? Give me an example. What's the technology that makes PANs possible that we typically utilize for PANs? Yeah, it's a personal area network. usually around you, right? You're the hub of that network. And Bluetooth is what we use. Like my phone's connected to my headphones, connected to, maybe my Fitbit, right? That's a personal area network. LAN, what's the difference between a local area network and a WAN, wide area network? What's the big difference between the LAN and the WAN? What's the difference between the LAN and the WAN? Not the first letter. What's the difference between the LAN and the WAN?
So LAN, like an access point, and the LAN like the Wi-Fi.
Not really. The big difference is a LAN is like, a local area network is like a physical location that I control the whole physical location, right? Like at St. Francis University, Schwab Hall has a local area network, and we can run cables, we can connect things through Schwab Hall. We own Schwab Hall, yes? But if I wanted to connect Schwab Hall to maybe it's Steubenville University, Franciscan University, to their business building, and we wanted to share things between us and Steubenville, that would be a wide area network. And that's because I can't run a cable from Loretto to Steubenville, Ohio, right? I have to contract with telecom companies that have cables that run between Loretto and Steubenville, Ohio. That's a wide area network, right? When it's not one physical geographic location, but it's still a network, it's a wide area network. And we also talked about the internet, capital I, and I should have that lowercase, and internets. So what is an internet and what is the internet? So an internet is a network of networks, right? The internet is a network of, when we network multiple networks together, that's an internet. Okay, a network of networks. The internet is what we call the public internet, the network of networks that we all get on, right? We could have our own internet, but it's not the internet, right? You could connect a few networks together and it's an internet, but the internet is known as the public network. Okay. NICs, what are NICs? What does NIC stand for? Network interface card. Those are the physical devices in your computer, the hardware that allows you to access either Wi-Fi or Ethernet or Bluetooth. Switches, kind of the thing that brings the whole network together. MAC address was the machine address of your physical device. Protocol, anytime you hear the word protocol, it's like how we're going to communicate. Ethernet is a protocol. TCP/IP is a protocol. Optical fiber is, the cable that we can use for long distance. Fiber optic cables communicate like at the speed of light. kbps and mbps, kilobits per second, megabits per second, that's the speed we see. Remember, Ethernet was 10, 100, 1,000 megabits per second. 802.3 is Ethernet, 802.11 is Wi-Fi. Those were the standard protocols that we use for connecting hard code and also Wi-Fi. Access point is that device that communicates with our devices via Wi-Fi and then translates that to Ethernet that's hooked back to a switch. ISP stands for Internet Service Provider. We talked about the advantages of why we need ISPs. We talked about packet switching. Remember the example I showed when I put the packets through our network and it went through the class. That's how things happen on the internet. TCP/IP is the protocol of the internet, transfer control protocol, internet protocol. Domain names, we talked about top-level domain names, like .com, .edu. Generic, those the country code top-level domain names like .uk, .ca. Domain name basically is the human-friendly address for every site on the internet. We also went through like a URL and kind of dissected each part of that, right? HTTP is the protocol, then we have the domain name, then we have the folder, then we have maybe a file name, and then sometimes if you see a question mark, those are parameters we're passing back to the server. Three-tier architecture, we just talked about that today. Talked about top-level domain names. Encryption, remember we talked about things need to be, because it goes through a network, things need to be encrypted with HTTPS. We talked a lot about the cloud, advantage and disadvantage. Those are in the slides as well. And then just today, we talked about software as a service, platform as a service, and infrastructure as a service. Okay, so a lot of material. This is kind of a lot of material, like chapters 4, 5, and 6. So the possible short answers, the 35 multiple choice will come from those topics. The possible short answers, there are 8. Once again, I will allow you guys, if you'd like, to lock in one and to remove one, if you'd like to do that quickly. So we have a nomination to remove 7. Would you guys like to remove 7? Second on that nomination? You want to fail for lack of a second? I'm proud of your second. Yeah. All in favor of removing 7? No. Is it different? Is there another nomination from the floor to remove? 4. Who said that?
Second.
Who said that, Dan? Your voice has changed too, Dan. It's not like your voice. So Daniel is recommending 4. Sawyer is seconding it. So how about 4? Moving 4. Can't show of hands, please. 3. That's like 6. Doesn't seem like we have much consensus here. So 4 and 7 are the 2 nominees. So we'll just take a straight vote. Any other nominees? So who would like to remove 4? Show of hands. I'll count the hands. So we got 5, 6, 7, 8, 9, 10, 11. All right, I think. So what was that? 7? Did you start? 4. 4. All right, 4 is removed. That's more of an important word. So 4 is removed. Now, which of these would you like to lock in? So what do we say? 4 removed. All right, so 1, would you guys like to lock in? All right, 1 is locked in. It seems like there's a lot of consensus. All right. Now, one of the things, this is Monday, right? This exam is Monday. One of the things that you saw under Chapter 6 was there's, some of the material. There's a video called Modern Marvels, the Internet Behind the Web. This is a very well done video that I typically show in class, and we have about 20 minutes. It's about an hour-long video. I'd like to show today, I'm going to stop recording here.